To wrap up our lesson at the county fair, what we're going to look at here is several different systems of equations, and we're just going to straight out use substitution to calculate algebraically. We do need to be able to check our solutions, and the cool thing about this is these equations are pretty well set up for us with just minor little changes to make them work. This first equation we see in part A, we see that the value of y is already given as 5 times x. This is great for us because we can take that 5 times x, substitute for y, and then we get the equation, or we can substitute that value to get the equation 2 times x plus 3 times 5 times x, which is now y, is equal to 34. And now what we just simply do is we simplify these two expressions. We see 2 times x plus 15x is equal to 34, which makes this 17 times x is 34. Dividing by 17 on both sides means that x is equal to 2. And since I believe x is equal to 2, I need to substitute to both equations. So I'll start here with y equals 5 times 2, and I believe y is 10. And now that I believe y is 10, I have a solution that I want to check, and I think it's 2 and 10. I'm going to circle that if it comes out true. But what I need to do now is 2 times 2 plus 3 times 10. And I need to verify if that really does equal 34. And I see that we have 4 plus 30. I know that equals 34. Verified. My solution is 2 and 10. For the next problem, I see that y is equal to 4 times x plus 2 and y is equal to 3x minus 2. Since I see these equations are both in slope-intercept form and I recognize the slopes are different, I know that I'm going to have one solution because these slopes will make intersecting lines. Since both equations are equal to y, I can simply take the expression 4x plus 2 from the first equation and substitute it for y in the second equation. Give me 4x plus 2 is equal to 3 times x minus 2. And I can say that they're both equal because they have the exact same value for y. Following the properties of equality, I can subtract 3 times x to eliminate that value there, giving me 1 times x plus 2 is equal to negative 2. Subtracting 2 from both sides tells me that x is equal to negative 4. Once I know what x is, I can go ahead and substitute into these equations. Now what I'm going to do is substitute for both equations. And when I substitute negative 4 into both equations, if y comes out to the exact same value, meaning if these expressions simplify to the same value, then I know that I have my solution. So we'll go like this. We have y is equal to 4 times negative 4 plus 2, which is negative 16, plus 2, which tells me that y is negative 14 for the first one. The second one, y is equal to 3 times negative 4 minus 2 is y equals negative 12 minus 2, which also equals y is negative 14. I see that they're the exact same. So that tells me that my solution here is x. When x is negative 4, y is negative 14 for both, and I know my solution is true. Letter C will offer just a little bit more of a challenge. The first thing I want to look at is take a look at these first expressions. I see that my expressions are different in the x's and the y's. This tells me there will be one solution. But I also see that I don't have any variables directly by themselves. So this one might take a little bit more work, but I can take 2 times x minus y equals 5. And I can switch the 5 and the y around by adding the y to this side and then subtracting the 5. So it would end up looking like this. I would get 2 times x minus 5 equals y. And when I know what that y is, I can go ahead and substitute this value or this expression to the top expression, 3 times x plus 2 times x. Whoops, that's twice the value of the y. 2x minus 5 is equal to 4. And then from there, it's simplifying and solve. I'm just going to go ahead and do this really quickly. X should be equal to 2. And now I can go ahead and go back in and substitute these values. I'm going to go ahead and use my space over here and see that I have 3 times 2 plus 2 times y equals 4. That would be 6 plus 2 times y equals 4, and I subtract the 6. 2 times y equals negative 2, dividing those by 2, and y should be negative 1. If y comes out to negative 1 in the other situation, then I should be good to go. I would see that I have 2 times 2 minus 1 is equal to 5. And that would be, whoops, not 1, y. You know what? I'm going to just use substitution to verify this. I should be able to have 2 times 2 minus negative 1 for y equal 5. That's 4 plus 1 equals 5, and that comes out true, which tells me that my solution is 2, negative 1. And I know it's going to be true. The last one that I'm after, I need to get this y all by itself, which means subtract the 3x, which would take this to y is equal to 8 minus 3x. And now I can simplify, or I can substitute this value for y in here. 6 times x plus 2 times y, which is 8 minus 3 times x, is equal to 10. 6 times x plus 16 minus 6x is equal to 10. And I notice something. If I skip over that plus 16, I see 6x minus 6x, which equals 0. And that would eliminate these two values, leaving me with 16 is equal to 10. That's a false statement, meaning that these two equations, there is no solution. These two equations will actually be parallel to each other, and I'm going to throw in one more little secret trick for you. See how they have this 6, 2, and 10? All of those can be divided by 2, which means I could ultimately change this bottom equation by a factor of 2 to 3x plus y equals 5. And you'll notice that 3x plus y equals 5 compared to the other equation, 3x plus y equals 8. We see that the a term and the b term are exactly the same, but the c term is different, which means these have the same slope and different y-intercepts. That's enough of the talk. That's enough of this lesson. The final stuff that's left is the summary and the work. Remember, the last little pieces that we need. When a system has no solution, the equation resulting from the substitution step has no solution. So this is when we see that we have a false outcome. And a system that has infinite solutions will come out with a true outcome. That's it. Thanks for tuning in and hanging with me in all of this. Have a great day.